Welcome back. So we just looked at inserting items or nodes at the beginning of a linked list. Now we're going to look at the opposite. We're going to insert at the end. So if we look at our simple linked list that we created in the last example, we realized that we were always looking at the head because it always points towards the start. But what points towards the end? I know that if I want to add to the beginning, I'm going to look at the head. What about the end? Well, it's actually the same thing. Once you get to a node that points towards nothing, so you can see that in here, this node is pointing toward another node. This node is pointing again to another node, but this one is pointing towards nothing. That means we have reached our end. So taking that into account, it's going to become very simple to program it. All we need to do is to traverse our linked list, starting from the head, from the beginning. We need to traverse, which means going from the first item all the way to the end, and then we want to add an element right after it. I'm going to start in here. So we are going to start with a simple comment. So let's say inserting a node at the end of list. Then I'm going to define a new function or a new method. Let's call it insert at end. Again, I don't need anything but the data. Okay, because I know that whatever is going to come at the end is going to point towards nothing. That is where I want to insert. So I don't need a location. All I need is the data. So self and data. Starting in here, I'm going to do the same thing. What if this linked list or this node that I wanted to add at the end or insert at the end was actually the first node in an empty linked list? And this is very similar to this code in here, which is when we added at the beginning, we asked what if it was empty, and I'm going to do the same in here. But before we do that, let's create our node, because in here what we did was create the node twice, and I can in reality do this. So I can come here, create it once, and delete it from here. This is to make the code smaller and easier, because why am I doing something twice if I can do it once? So create the node. If it was empty, then make it the first node. If it was not, then stick it at the end and make head point towards it. I'm going to do something that is kind of similar in here. And what I want to do is start with creating a node. So new node equals node for that data. So I'm creating my node right here. Then what I want to do is use either the name current or previous. When you look at the code in the printing method that we have in here, which is this one, we created current and we said, well, current is something, is going somewhere. It's not pointing towards nothing. Then you can go. And I'm going to do the same in here, but I'm going to use the while with a none. And this is just to show you that we can use both methods, not methods, but both ways in the while loop. You're going to know what I mean in a few seconds. So what I'm going to do next is instead of calling it current, I'm going to call it previous node. This is just a name. You can use current, it's not a problem. So previous node, and this previous node is going to start at the head. Why? Because I want to traverse my linked list. I want to start here, then jump and jump all the way to that. So previous node, always when we use more than one word, we are capitalizing not the first, but the second and ongoing words. This is called camel casing. So what I want to do in here is ask the same question that we did ask earlier, which is this first is this the first node? Is this a node in an empty list? Exactly like what we have in here. But instead of using self.head, I just said previous node equals self.head. So I can do if previous node equals none, or I can use the same thing, which is if self.head is equal to none. Now some of you might ask, okay, then why are we doing this in here? Because we're going to use it later in the else. So if this was actually the first item, if this was real, so this head was pointing towards nothing, and even though we are using insert at the end, but in reality we are inserting in an empty list, then we're going to do the same thing that we did in here. I can actually even copy and paste it. So it's going to be self.head equals new node. We're saying, look, it's empty. Okay, so just make the head point towards the new node that you created. Now I'm going to go with else. What if it wasn't the only node in the linked list? As an example, this example here. So right now my linked list has 0, 3, and 5. And it said, is self.head equals none? Is this equal to none? No, it isn't. It is pointing somewhere. So new node, let's say that the data that I received in here was the number 4. Okay, so it created a node with the number 4 in it. Okay, so after that, let's again increase the size to make it more visible. And right now we created the node. We said, is self.head none? No, it isn't. Okay, then we are jumping to the else. So what do you think is going to happen in here? In reality, it's going to be a simple traverse. Exactly the same as this one in here, as this point, while current is equal to something. But I'm going to use the second type, which is the one that you already know, or that you have already seen, which is while previous node dot next is not equal to none. Now, why are we using this way in here? That is because I want to stop at the last location. Now, with while current, this is going to stop 1 in here, 2 in here, 3 in here. Then it's going to stop here. It's going to stop when my pointer itself is none. Okay, so that means the pointer is going to jump from head to here, first node, second, third, and this pointer, the next pointer of this node is pointing toward none. So it is going to jump to none because in here it says current equals, it takes the value of current.next. So if this value, the next value is none, then current is going to equal none. I don't want that. I want to stop at the end, not go all the way after it. So what I want to do in here is instead of saying while you are not none, I'm going to say while your next pointer is not none. So in here, is this pointer none? No, it isn't. It is pointing towards something, so it is going to jump. Same here. Is this pointer, the next pointer of the 3, is it none? No, it isn't. It is pointing towards something. Is the pointer of the 5, the next of the 5 is none? Yes, it is. So I know it's stop in here. And this is exactly what we're saying. We're saying previous node, which started at self.head. So it started exactly at the beginning. We're saying while previous node.next is not none, what I want to do in here is just do a normal traverse. And it is going to be just one statement in here. Okay, so we forgot the colon. And it's going to be previous node. This is going to equal previous node next. So let's say I'm going to take this small triangle and say this triangle is previous node. And at the beginning we said previous node equals self.head. So right now it is pointing towards wherever head is pointing. Then we said, is previous node, so this location's dot next pointer, the next pointer, is it none? While it is not none, is this none? No, it isn't. So this is a valid condition, so it's going to jump inside of it. We said this previous node equals wherever this node right now, previous node dot next, wherever it is pointing. So it is actually pointing here. This is going to take my connector and change it. Again, it asks the same question. Is your next pointer, this pointer, because I'm pointing here, this is a previous node right now, is the next pointer none? And in reality, no, it isn't. So is it not equal to none? Yes, it is not equal to none. What do I do? Your node, this previous node, equals previous node dot next. Again, doing the same thing. Just to make it a little bit bigger and easier to control. Same thing. Now, when we look at this item in here, or this node in here, and ask the same question, while previous dot next, this previous, the previous node dot next is not equal to none, but in reality in here, it is equal to none. This node is actually pointing towards none. So this condition is now false. It's not working. So it's going to jump right after it. And what I want to do in here is insert this node in here. And when you think about it, look, I know that I'm in here. I know that I am at the last location. And the last location always points toward none. I want this to be the last location. It is already pointing towards none. So I don't need to add anything to the end of it. But I want this node to point toward it. And that is very, very simple. All I need to do is write some code in here. Previous node dot next equals new node, and that is going to do this. Now when you think about it, it is the last node. It became the last node in our linked list. So taking that into account, it is very, very simple. It's a simple traverse that starts at the beginning, jumps until it reaches a node where the next pointer is pointing towards nothing, takes my new node, stick it in there, and make the previous node. That is why we call it previous node. It's the node right before the node that we want to add. Let's take another example, just for to make it more obvious. So let's say that I take the number 9. Okay, let's take number 9 as an example. We haven't used it so far. So this data is 9, and I'm going to create a new node with that 9. So again, create a new node in here. The number is 9 and 20. And previous node equals self.head. So what happened is, let's make this more obvious. Okay, so what happened is previous node, so this pointer equals node.head. It started at the beginning, and it said, excuse me, while previous node, while where I'm pointing right now, dot next is not null, I want you to jump to that location. So is this next pointer null? No, it isn't. Okay, then previous node u equal your next, previous node dot next, and it did that, jumped here. Again, is this none? No. Is this none? No. Is this none? Yes, it is. So we stopped and we jumped right here and we said, okay, this node's next pointer, previous node dot next, equals new node. So new node is in here, and it is inserted at the end. As you see, it is really simple. Even if you look at the code, I'm taking too much because I'm trying to explain it, but when you look at the code is very simple. I hope that you enjoyed this lecture, and I'm going to see you on the next lecture where we insert at the middle. Thank you for listening.